data transfer sound right in the middle of that, but anyway. Welcome everyone. This next talk we have Sam. Thank heavens he has learned about the match statement because I haven't, but I'm about to learn. So thank you, Sam.
So yes, hi. I learned everything about the match statement. But first of all, who am I? I'm Sam. I'm doing IT and cybersecurity at UTS, nearly finished. I first started coding Python when I was 10, and this is actually my 4th time presenting at Pycon, thanks to the student showcase. I've only done those so far. Anyway, Python has a match statement? Yeah, so in 2021, with revision Python 3.10, the match statement was introduced. Most people I talk to who code Python haven't heard of it or don't see a use for it, which is why I'm making this talk. It is quite useful, I promise. Now, first of all, why wouldn't we use an if statement? If statements get pretty good, but they also get bulky at times. As a quick example, we'll look at later, but the most important bit now is it is just a little bit hard to read. Now, generally, you wouldn't just use one if statement to check all of these things, but then you would end up with greater nesting, and still, the code gets pretty hard to read. The main takeaway is checking of types is pretty bulky, checking multiple attributes of a variable is bulky, and long if statements just kind of get hard to read. Now, match statements, most languages tend to be just kind of rearranged if statements. They don't check anything else. They might save a little bit of performance, but most of the time, they don't do anything special. However, Python's match statement is a bit more like what you'd see in functional languages, like Haskell. It does pattern matching, and it's called structural pattern matching for that reason. It's good at doing interesting things with checking patterns of variables. Now, some quick comparisons. When you're matching against constants, match case doesn't really do much more. It's about the same size, about the same brevity. On the left, for each of these examples, is going to be the if statement. On the right is the case statement. Pretty simple. Now, the first non-standard thing is that the match statement can check types really well. Now, I'm using isInstance here because unlike the type function, it can check like subclasses of variables, which isn't that useful for built-in types, but it will come up later when we talk about classes. Now, this syntax of match statements works with every built-in class, sorry, every major built-in type, and we can check the type and the value at the same time. Note that integer1 and float1 are matching separate values. They won't just override each other. Now, one of the main reasons you'd want to even check the type of variable is because of Python's often pretty useful, but sometimes hard to predict type inference. It means that sometimes you aren't certain of exactly what type of variable is at runtime, and with the match statement, it's really easy to check and act accordingly. Now, one of the most important things about match statements is they can do this thing called a capturing match. If you put anything that looks like a variable name inside a match statement, inside the case rather, it'll store the matching data in that variable. Note that if the variable is already defined, it will be overridden, as you can see here, but this isn't very useful if we only just put in a variable, because it'll match on anything, but it can be pretty useful when you combine it with other things. Now, also, with match and switch statements, you often have some sort of default case. That's not exactly the same thing in Python, but you can match against an arbitrary thing and store it in underscore, which is just the syntax for showing you're going to throw something away. It's entirely possible to have a match case that doesn't hit at all, it just gets passed by, just like you can have an if statement that doesn't have an else. Now, sometimes, quick aside before we get into the rest of the things, because of how useful capturing matches are, I'm going to be using the walrus operator a lot. Sometimes, when you're doing a Boolean check, like with a condition, you also want to store a variable at the same time to improve brevity. This is one of the most common if statements you'll see, especially in beginner code. You're writing a variable once, and then checking at the end of the loop to see that it exists or that it matches some sort of condition. And you can do that with the so-called walrus operator. That's that colon equals there, because it looks like a little walrus face. Now, match statements start to get pretty useful when we combine captures with sequences. You can see so far, we can use what we've seen so far to match on collections and capture their items. Note that we can check a constant and store something variable at the same time. Now, what if we're not certain of how many things we want to store? Well, similarly to functions and arguments, we can use the star operator or star operator to store an arbitrary amount of variables or keyword arguments. We're getting to the point where you probably wouldn't do most of this inside a single if statement, but I did my best to replicate exactly the same functionality on either side of the examples. Now, here's what it'll look like with the star capture. It's really useful when you're matching on mappings like dictionaries. You absolutely would not do this in an if statement. That looks terrible. You shouldn't do this, but it shows how much code the case statement can bring into one line, into a short, readable statement. You can also use the as keyword to manually choose if you want to capture something. For example, if you have a set type of things that you want to collect, but you want to store that in a variable to see which one was matched. You can also combine all of these things we've seen so far to make more complicated and more useful matches. For example, this. You can check inside a dictionary with an array, with a star match, and an as keyword, and keyword arguments. It is pretty useful. Now, not every if statement can directly correlate to a match statement, but in that case, we can use a postfix condition to provide some of this information if there are some parts of our condition that do make sense as a match. Please don't try and replace every if statement you write with a match case. It won't work, and it will generally tend to look worse in some cases. Now, the biggest superpower of match statements for me, and the entire reason I ended up making this talk, was their compatibility with classes. To demonstrate all the ways this can work, I've made up a few classes just for an example to show some shapes on a plane. Here we have a point and a shape class, and a circle, a rectangle, and a square. The circle and rectangle are shapes, and the square is a rectangle. I'm going to show you through some of the interesting ways you can use the match statement with classes just by demonstrating with these objects here. For the first demonstration, there's a method we could write for the shape class to return the area of a given shape. This is definitely not how you should implement this, but it'll help me show matching with classes. First, you can check the class of a variable just like you would a built-in type. Pretty simple. First one is a match on just the circle class, and it works fine. You can also match against attributes of the class directly with a keyword match. You can see here that we match against a shape that has the attribute side. Only the square class before was defined with a side as an attribute, and so it matches only squares. You can also do what's called positional matches using the class variable we defined, match args. You see back here in the rectangle, the match args are a point, a width, and a height, which are the attributes that the initialization of a rectangle takes in. What that does is converts each of those positional arguments to a keyword argument using that list we gave it. So we're directly checking against the point attribute, the width attribute, and the height attribute, because that's what we defined here. We can then store those using a capturing match and return something based on that. The next one, where it gets to where it starts to get a little bit crazy, is a method to return whether a passed-in point resides within a shape. What this can show off is the circle match takes in a point and a radius, as we define up here, using the positional translation to like the keyword attribute. We can check the point inside and capture the x and y positions, x and y attributes of the point inside the match. I don't think I'm explaining that very well. We can also do complex checks with postfix conditions, like the rectangle match here. Definitely don't do it like this, but this is to show off how you could possibly do it. And you can also have multiple matches on the same type, of course. That is my talk. It's definitely too fast, but I guess I get some questions.
Thank you, Sam.